Welcome to the Geometry Final Review. This is Standard 9 Part 1. What we're basically going to do in this one is go over some of the ideas that we use with circles. I've tried to gather some of the key ones. There won't be a whole lot of examples, but there will be some pictures and diagrams that may help you kind of sort out some of the different properties that we're able to use. In Part 2, I hope to get to the actual problems. And so if you're looking for just how to do the problems, then that'll be in Part 2. Okay, so when we started our unit on circles, the first thing we need to kind of do is get some idea of what a circle is. Okay, a circle is a set of points that basically surround an area. And those set of points have a special property. They're always the same distance from a place we call the center. Okay, so this outside edge is actually our circle, and the inside is our area of that circle, the area that it encompasses. Okay, the distance around the circle, same as perimeter of a circle, we have a special name for. We call it the circumference. Some names that you already are used to: center, a measurement of something from the center to the circle itself is called the radius. If it goes all the way across and it goes through the center, it's called the diameter. And the diameter and the radius are related because the diameter is twice the length of the radius. If I just connect any 2 points on the circle, it's called a chord. Now there's 2 other ones that we learned a little bit later. If we have a line that goes through the circle or touches the circle at 2 places, it's called a secant. Secant is very similar and in many cases acts the same as the chord. And if we have a line that basically comes and it touches the circle just in 1 point and then it goes on, it is a tangent line. A tangent is always perpendicular to a radius. That'll come in handy later. Okay, we learned first how to find circumference and area of circles. Most of you have done circumference being 2 pi r. But what if I have just a piece of that circle that I want to find the distance of? Okay, so if I'm finding just a length of that distance, I modified the formula and said we'll take the central angle, divide it by 360, and then multiply it times 2 pi r, the regular circumference formula. This is basically accounting for the part of the circle. This later on will also be given a special name. We're going to call it arc length. And it is arc length, and so the arc length of this space is also found using that same formula. Okay, next we looked at area. We can find the area of a whole circle by doing pi times the radius squared, or if we're looking for just a region, like this region here has a measurement of 50 degrees. In that case, I would put 50 over 360. Whatever that central angle is over 360 times pi r squared. Same as with circumference. This is basically just telling us what the part is. Okay, now, when I look at this, this is my center right here. I have 2 points on my circle, A and B. If I look at this, it creates 2 arcs. One arc, the smaller arc, is called the minor arc. So that would be minor arc AB. The larger arc is called the major arc. Typically, not always, but typically the major arc will be more than 180 degrees and the minor arc will be less than 180 degrees. Okay, if I have a radius and it's perpendicular to a chord, it will bisect the chord. So one of the methods of bisecting a chord is finding the perpendicular bisector, and it will go through the radius. If you take 2 chords and do a perpendicular bisector, so like here's one, and then you were to do maybe another one over here, that's an easy way to find the center of a circle. Okay, so the radius, a radius that is perpendicular to a chord bisects the chord. Okay, an inscribed triangle. Okay, you can inscribe all sorts of triangles into a circle. I could make one that went from here to maybe down right here, and then across, and then back up to where it was. You can do that, and that's fine. But there's a special case of one. If one of the sides of an inscribed triangle is the diameter, or is a diameter, then it will always have a right angle. So it's going to be a right triangle. Okay. If we inscribe a quadrilateral, any quadrilateral, in this circle, inscribing meaning that all the points are on the circle, we found that those opposite angles, if we add them, they will equal 180. Or the other word we use for that is that they will be supplementary. Okay, now let's talk about arcs and the measure of an arc. A measure of an arc is different than arc length. Arc length measures how far it is from here, going around the circle, to here. The measurement of an arc is actually the measurement of an angle. So like here, they tell us that the measurement of this arc is 74. That tells us that the angle that the arc forms with the center of the circle is 74 degrees. So if this is 74, then the measurement of that arc is 74. We learn that if we have an inscribed angle that basically has the same arc, the same intercepted arc there, that it will have a relationship. Now remember that this angle this point right here has to be on the circle, and they have to have the same intercepted arc. If they have the same intercepted arc, then this one here will be half of the arc's measurement. So if this is 74, then this is going to be 74 divided by 2. I'm not sure what that is. Let me see what it is. Should be 37. So that would be 37 degrees. Those are all degrees, by the way. Okay, so the measurement of that central arc, or that central angle, I should say, is the same as the measurement of the arc. And this one, this inscribed angle, is going to be half. Okay. Okay, several others we're going to do really quickly. We found out that we could find the measurement of angle X if we took the measurement of this arc and added it to the measurement of that arc, and then found out what half of it is. So that will equal half the measurement of those two arcs. Okay, go back for a second. Notice that these cross inside. Okay, it's going to be important for a moment. Okay, if you're, this is two secant lines, but basically if the angle formed with the arc, for example here CD, is outside the circle like this, then it will be half of the difference of those two arcs. So half of this, take away that. So take the larger one, subtract the smaller one, and that will give you your angle. Okay, this is one we really didn't cover, but I'm going to throw it in just in case it's useful. If I know the measurement of an arc, for example the arc SV, and I have a tangent line that also goes through one of the endpoints of that arc, the angle that it forms will be half the measurement of the arc. So that one might be useful. Okay, I think that pretty much goes through all of them. In part 2, we will use some of these to find some measurements and some area and some other kinds of things inside the circle.